Hello everyone, welcome back to Pre-Calculus. In this video, I will be talking about one of the very important concepts we already covered in intermediate algebra and college algebra. And maybe some of you asking me like, why we have to go through this concept again? If you see, the pre-calculus is nothing but a bridge between college algebra and calculus, right? And the concept I'm covering in this video is called function. So when we're doing a calculus, we're going to do another analysis on how the function is disconnection or how the function behave in calculus. So in this video, okay, we are doing nothing but like a quick review on what function is, and I introduce a new concept we call the concept of continuity. Then we're going to go through on the basic graph on the function that we already covered in college algebra. Okay, so this is our chapter 2, and we're going to talk a little bit about 2.3, which is the function here. And then I'm going to go through on the graph of the basic function. Then in the new video, where we're talking about function and operation and composition. Okay, I have to say with you that I lost the video of my talking and writing at the same time. Just 10 minutes ago, somehow I recorded and I saved it and it lost, and now I have to go through there again. But I have all the file of me writing, but I don't, you know, I don't have to go through writing and talking at the same time anymore, okay? Because I already have it here, okay? So let's get started. What function is, the concept we already covered in college algebra. So I'll put the topic today will be function and graph. So the first part we will be talking about the definition of function. A function is a relation between two sets, and the notation of function is y equal to fx. We already know this. And x is called the input, and y is called the output. X is an element of the domain, and y is called the range, right? And y equal to fx, so that's why fx is considered as the range also. And x is we call the independent variable. So the y value depends on the x, so that's why y value is called the dependent variable. But the thing is that not all the relation is considered as function. The relation must have a rule, and the rule is this: if you have one input, it assigns a unique output. Because if you have one input and it assigns two different output, then we don't call that function anymore. Okay. Graphically, that is when we talk about algebraic function, which is you have fx equal to something. But what if we give you the graph? So graphically, in order to know that graph represents function, we have the vertical line test. In my last time in the video, we already talked about vertical line test. You have the circle, and you see you draw a straight line, a vertical line. You see they cut at 2 points. So that's why we have called the circle is not a function. Okay, so that's what a vertical line test for. Okay. However, in this course, I also want to introduce a new concept we call the concept of continuity. So what is continuity? Over here we say that if the function is considered as continuous on a certain domain, then its graph has no disconnection in that domain. I mean disconnection. I mean a hole or jump. Okay. If you have a hole or jump, or you have a vertical asymptote, then maybe your graph has too many branches, then that function is not continuous from negative infinity to positive infinity, but it may be considered continuous on a certain domain. Okay, for example here, I have a graph like this. Okay, and this graph over here has a hole at 3. So this graph here is not continuous from negative infinity to positive, but it's still continuous from negative infinity to 3, and from 3 to positive infinity. So it is continuous from It's continuous from negative infinity to 3, union 3 to positive infinity. Okay? But it's not continuous on the domain. In the second example, you're going to see that this is not continuous at 0. So it's continuous everywhere. Okay, continuous everywhere. Okay. And over here I have two pieces. It's not continuous at 1, but it is continuous everywhere. Okay, continuous. It's not. That's why they have a continuous from negative 1 to 1, and negative infinity to 1, and union to 1 to positive. You see, I don't put a bracket here because it's jumping. You see, this is jumping. You see over here, you draw a straight line, it jump to another branch right here. So this is a hole. This is a jump, and this is where you had a vertical asymptote, right? This is a vertical asymptote right here. Okay. Vertical asymptote. Okay. Alright, so that is the definition of continuity. You know, when you go to a higher level in college, in calculus, then we'll be talking more about what continuity is. When we have a new concept of continuity, mathematical concept. But this is informal. Let's say this is an informal concept. It's not mathematical. This is informal definition. It's not a mathematical definition at all. Okay. When you go to a higher level, calculus 1, calculus 2, calculus 3, then we'll be talking more about continuity. I'm sure that everybody over here has had to go to the calculus. I don't know if anyone's just taking this class and you stop right here and you don't have to do math anymore. It's good. But I mean, if you guys go in high level engineering or anything, you have to go higher than this. Okay. Then over there you would understand more about the concept of continuity. But at this level, I think that's all you need to know. Okay. Now on the second part of our lecture, where we introduce again all the basic function we already cover in college algebra, which is nothing but a review, right? The first few section is just nothing but a review. And the first function over here I want to talk about is called the identity function. Identity function is a basic linear function. So you see that it's y equal to mx equal x. You see the slope over here is 1 right here. And this graph over here is represented by the straight line. The straight line makes a 45 degree with the x-axis. And you look at this, the domain goes from negative infinity and the range goes from negative infinity to positive infinity. All of this. This is continuous everywhere. So this is continuous from negative infinity to positive infinity. Okay. I'm telling you that I just hope that I'm not losing this video one more time, because every time I say this like 45 minutes I'm tired. Okay. Hopefully I don't want to lose this video again. Okay, so this is continuous everywhere. It's continuous everywhere. Okay, and you see that the b, because this is a basic linear function, the b value, the y-intercept value is 0. Okay, the slope is just 1. But you can do something more. You can add 2 over here. You can add 5. Okay, that will just give you the linear function y equal to mx plus b. So this is the standard. This is the very basic one. Okay. The second function we call the square function, and this one is the basic quadratic function. You know, quadratic function they look like this. All right. F of x equal to ax squared plus bx plus c. And for linear function, the full form is actually f of x is mx plus b, right? And you see that it does not have the b and c, and that's why we call that's why it's the basic one. And it had a parabola like this, and it go from negative infinity to the domain, and the range also go from 0 to positive infinity, because there's nothing down here. And this is continuous. It's continuous. This is continuous. Continuous. From negative infinity to positive infinity. There's no hole, right? There's no jumping and no hole. Everything's smooth. Everything's smooth. So no hole, no jumping. Okay? And the next one is the square root function. Okay, the square root function is the basic radical function. Okay, so we have y equal to fx equal to square root, and this is for all the even root, not just the square root. Which could be like 4th root, the 6th root. The graph of all the even root function is always like this. Okay, it's always like this, and it go from as of course this is included, so from 0 to positive infinity included for the domain and range, and as you see, and from this, because this is basic one, we can derive the more complicated function by using the transformation concept. You know, you can add, you can introduce, you subtract here. You add mean you move it up. Remember the transformation. You minus inside mean you move it to the right, and two it mean that it's elongated, it's spaghettified along the y-axis. Spaghettified along the y-axis. Okay. And of course, this one is also continuous, right? It's continuous on positive, 0 to positive. Okay, but this is the graph for all the even root. What if it is odd root? The odd root is the basic one will be the cubic root, the cube root function, cube root left. Then you have something like this. Something like this. Okay, and the domain and range is this, negative infinity to positive. And this one you see that it's continuous everywhere. It's continuous on infinity to positive infinity. Okay, and you actually in this one you can derive more function if you want it. You can you apply the transformation concept too. You can have something like this. You have 1 over 2 the cube root of x plus 1 minus 3. I mean, this is what this is mean. This is moving to the left, moving down, and opening up. Okay, opening up 1 over 2. Okay, it's opening up. It's compressed down. 1 over 2 compressed down 1 over 2 by a half. Okay, or vertically. Okay, it's a concept of transformation. Then the next function we have the absolute function. We have something like this with the letter v. And you see that over here is also continuous from negative infinity to positive infinity. And we just see the range. The range in the domain here. The range is going to go from 0 to positive infinity included, and the range from negative infinity to positive infinity only. Okay. I think I know why I lost the video. I think just because I did not using this. Okay. I forgot to plug in the power, so it cannot save. But that's anyway. That's just, it's like 20 minutes ago I lost it, but that's okay. I think hopefully everything is fine. Okay, and you can apply the transformation in the absolute function. It's easier to go over 2, negative 1 plus 1. This is more complicated, and every time you grab this function, you can use basic traditional way. You set up the table, you plug in the value, or you can use the transformation concept. You grab the basic one first. This is all the basic one. Then you move left or right, correspondingly, according to the transformation concept. Okay, if you guys forgot the transformation concept, please go back and review it. You can send me the message if you want to do a quick review. You ask me a quick question, I can reply to you really fast. Alright, and the next one is a rational function. And a rational function, you see that there's two different types, 1 over x and 1 over x squared. And this one is for even. Okay, and this is a typical example of even exponent. But this is for this is odd. I'm sorry. This is odd, and this is even exponent. Okay, and this is what it look like. If it is odd, this will look like this. It's two different branches, and you see they have vertical asymptote right here. It means that this connection right here, it's not. So that's why it's not continuous on negative infinity to positive infinity. And for this one, it's same thing. Okay, same thing. Yeah, it's not continuous from negative infinity to positive infinity. So but it's still is continuous. Both of this is continuous on negative infinity to 0, 0 to positive. Okay. And the next one is polynomial function. Polynomial function, actually all the function we had it here. This is the first degree polynomial. This is the second degree polynomial function. Then we have another typical example of polynomial function is the cubic function when you have the third degree, and this is the graph. And you see this continuous everywhere. No hole, no jumping. Okay, no hole or jumping. And it go from negative infinity to positive infinity, and negative infinity to a positive infinity as the range. I mean, in general, actually, the polynomial function look like this: x of n, x to the n, x minus 1, x to the n minus 1, and so on. But you have to be careful. It's the n, all the exponent over here must be integer. Okay, so I'm gonna add a little bit over here. So exponent must be positive. It can be negative, okay? Because if it's negative, then it's not it's not polynomial function. It becomes a rational function, because if you guys remember that you have negative exponent, you flip it over, right? You flip it over, it becomes rational. You got x raised to the negative second, and you flip it over, it can become 1 over x squared. So in that case, 1 over x squared is this. It's a rational function. Okay, so you have to be careful right there. Then the final one is the greatest integer function. Essentially, this one probably some of you have not learned in college algebra. Sometimes we call it step function. There's some of you have seen this before, to be honest. And an integer function is noted as this symbol. So in your calculator, they put int x. Okay. And in your calculator, this is a symbol. It's int, mean the integer function. And this one in this course we just cover the greatest integer function. We don't have the smallest integer function. It's a little bit different, but still considered as that function. Okay. So what is the greatest integer function? It is the output. The output is the closest integer that is less than or equal x. Or kind of hard to imagine what does it mean over here. Just look at the table over here. Okay, I'll explain it to you. If you have 0, then the integer of 0 is 0. But if you have 0.5, the integer, okay, that's smaller than 0.5 and the closest to 0.5 will be 0. It will be 0. If it's 0.7, the smaller integer, that's smaller 0.7, but closest to 1.7 will be 0. But if it is 1, it will be 1, right? But if it's 1.5, the smallest integer that closest to 1.5, but smaller than 1.5, will be 1, and so on. What if it is negative 1.5? Negative 1.5 is right over here. If it is negative point, the smallest integer that's closest to negative 1.5, but smaller than negative 0.5 will be negative 1. So that's why we have the function like this. Yeah, we have this is called a step function. It's a step function. At 1 will be 0, will be 0, 0.5 will be 0, but at 1 over here, they jump to 1 right here. Okay, 1 right here and 2 right here. Okay, this is negative 1 and this is negative 2. Okay, and you have a step function and go all the way up and go all the way down. That's why the domain we have a bunch of different interval from 0 to 1, from 1 to 2, and so on. So I put a bunch of union sign right here. So, union. And the range will be all the integer. It will be negative 1, negative 2, 0, 1, 2, 3, and so on. So put we gotta keep going. We keep going. But this continuous, right? there's a lot of discontinuous. So discontinuous is continuous everywhere except where? Except where? You know? Except for all the interval right here. So this is continuous everywhere. It's continuous everywhere. I mean, this discontinuous. I'm sorry, because it's jumping. Okay, it's jumping. So this continuous, jumping. Sometimes I confuse between this continuous and continuous because of the word, you know. Sometimes I say too fast. So it's discontinuous. Okay, it's continuous here, but at here it's not. Okay, it's not. Okay, because it's jumping. Okay, because it's jumping. All right. Now let's go back to this one. It looks like this, right? It kind of jump, but it's two different curves right here. But it's still continuous except for this one right here. Okay, it's continuous, but it's jumping. Okay, but it's not continuous or not. Okay. Okay. And you look at the example in the textbook, we have a kind of same thing, but the graph is a little bit different. They have a hole, but I mean, kind of the same thing, you know. Now let's jump to the greatest integer function. So let's see. Okay. Yeah, see over here, just say it's constant. It's discontinuous. You see, it's discontinuous on the domain. Okay, from negative infinity. But if you look at, it's still continuous on a certain part, but it's on the whole domain. It's not continuous because it's jumping. Okay, it's not jumping. It's jumping. Okay. 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 Now, so all of this function here, the basic function, actually there's another one called exponential function and log function, but I mean in pre-calculus we want to cover that one more time. So I'm not putting those functions here because if you look at the what we're supposed to cover, you see the in chapter 4 we're gonna cover exponential and log function again. Okay, so I'm not gonna put exponential for log function. Even the rational and polynomial function we cover one more time. So anyway, so though this is a basic function, and all the basic function you can combine them together. You can combine them together, and when you combine them together, we have a new function. We call that a piecewise function. Okay, and the piecewise function is just piecewise function. Of course, is not continuous because it's piece by piece, you know. So it's not continuous on the whole domain, but it's probably continuous somewhere on a certain part. You know, on a certain domain, or a certain part of the domain. Okay, and the piecewise function is nothing but a combination of many functions. It could be more than one, more than two, and the domain and range. Okay, the domain and range. The domain could be how the function define on certain part of the number line. Okay. That is where the function defines on a certain part of the domain. Okay, so what if I have something like that? What if I have so I'm going to put over here says a piecewise function is a combination of more than one function. Okay, and it is defined on certain part of domain. Okay, Okay, sometimes the domain is everywhere, sometimes it's not, and it's not continuous. It is not continuous on negative infinity to positive. Okay. Okay.
Voice amplifier.
Oh, check. 1, 2, 3. Alright. Now let me give you an example. What if I have this? I have piecewise function, and this piecewise function is a modulus function. Like, what if I have a linear function like this, and I have an absolute function? Okay, and this one defined on let's see, when x greater than or equal 3, and this is defined on x less than 3. Okay, this thing right here, this inequality, this is called a subdomain. This is called subdomain. Okay. Now, how are we gonna graph this? Well, we're gonna graph one by one, and we're gonna apply. We're gonna have. We're gonna graph it. We're gonna apply. And then we apply the subdomain. We apply the restriction. So x plus 2. This is linear function. Slope is 1. Started at 2. Okay. So we're gonna have something like this. 1 give you 3. 3 right here. 2 give you 4. And 3 give you 5. Okay, and it's greater than 3 only, so this is right over here. So usually we're gonna have something like that, right? Okay, but because it's greater than equal 3, so we're gonna have equal here and like that. Okay. Now, that is for x plus 2, and for this one, if x will be 1, 1 will be 3, 3 will be 3, will be right here. Absolute of 3 will be 3, so you can have right here. It's 2, 3. It's the open circle. So you will have absolute look like this. If it is negative 3, it will be 3, negative 1, negative 2, negative 3. So you're gonna have here. So you're gonna have something like this. Okay, it's not a straight line, so I'll try to get a straight line for you. So I'm gonna have something like this. Let me see, I can put. Alright, it's better. Alright, so you see that it had a piece in here and another piece. So there's no way it's continuous, right? No way. Even though it's defined everywhere. So the domain is everywhere. But it's not continuous. It's not continuous. So it's just continuous. It's continuous from negative infinity to 3. Okay. It's negative 3 and 3 to positive infinity. Because it's continuous there, but it's not continuous. It's not continuous on the whole domain. Okay, it's not continuous on the whole domain. Okay, it's so not continuous from negative infinity to positive, because it's the whole right here. Because it's jumping. I'm sorry. Because it's jumping. It's jumping. Okay, it's not smooth. It's just smooth here, then it jump. Okay. Okay. It jump right over here. Later on, when you go to calculus, you will have a mathematical definition of continuous. You will see. You will see. you get to talk with the definition for limit. You use that limit to define if it's continuous or not. Okay, but this is how you graph the piecewise function. I mean, there's more piecewise functions. You can combine more. What if I have something like this? You have f of x. Okay. You have what if you have x squared, and this is 3, and over here I have absolute of x plus 2. Okay, and this one you can define an uncertain info. You can define this with it is from less than or equal -2, and this is from between -2 and 5, and this is greater than equal 5. And the way you graph will be the same thing. Okay, we're going to be the same thing. So you're going to go ahead and do one by one. Okay. So I'm going to have x squared less than -2, and -2, which is give you 4, right? -2 here, give you 4. It's 1, 2, 3, 4. So you're gonna have something over here, and you have a parabolic curve like that. It's a curve, okay? It's the curve. Let me use different color. Let me use this one. So we have parabolic curve. Okay. Okay. Then between -2 and 5, you have 3. 1, 2, 3. So 3 here. 1, 2, 3, 4, 5. So because 3, so those should be horizontal line. So this 3 right here. So you have this open circle. Oh, this is still, I think, yeah, it's still a dot one. Then go all the way to 5. Open circle. Okay. Then the last one, you have absolute, and this one, let me use different color. You will have greater than 5, so that's greater than 2. If it is 5, it will be 7, 4, 5, 6. Oops. Yeah, I wish I can bring it down. So it's 4, 5, 6, 7. So 5 will be 7, 5, 6, 7. And you can make a dot here. Okay, and you're gonna have a straight line like this, because if it is 6, it could be 8. So you're gonna have something like that. There you go. So totally we have the blue, okay, the pink, and the yellow. So 3 different pieces. Okay, 3 different. So it defined everywhere, but it's not continuous from negative infinity to positive. It continuous on the yellow. It continuous on this. It continuous on each of them individually, but from negative infinity to positive infinity, it's not continuous. Okay. All right. So I think that's all for this section. Please let me know if you have any question or concern. Graph it. I mean, probably some of you have hard time with the piecewise one, but if you know how to graph the other one, then I'm sure we'll be fine. And remember that we can use the transformation concept to graph each of them, or you can use the table to graph each of them. Okay. There's another type of integer function we call the smallest integer function, but it's called step function. This should be this way, but I'm not. It should be this way, but is this included, is not included, but I don't want to talk about the smallest one because it's not covered in the textbook, so I don't want to confuse you. You don't see this function a lot throughout the whole semester though, maybe just in this section. But if you have any question, let me know on this, okay? I expect you guys to memorize all the domain and range and the graph of all the basic functions here, including the one I'm going to talk about next in the next couple of weeks, the exponential function and then the log function, okay? Try to memorize all of this. I mean, and the method of graphing the piecewise one, okay? Alright, I'm gonna stop over here, and please let me know if you have any concerns. Send me the message to Canvas inbox. Do not send me a message. Do not send me email, okay? Because I mean, I check every day, but the thing is that I have a lot of students, so I'm just afraid I miss your email. It'll be too late. I'll reply. I try to reply fast. So send me the message to Canvas if you have any questions regarding to homework questions. Take a screenshot of the homework of the question and attach it with your message. I'm gonna reply fast to you. Okay? Please do not use the one in my MATLAB Pearson to send me a question. I mean, I guess sometimes I cannot open it for some reason. It takes too much time for me to open them. Okay? Alright. I'll be seeing you next time for the new video. Bye.